Hey everybody, this is your first math video. This is take 2 on it, so some of the notes have already been filled out. I was recording it and then my iPad just ran out of memory space, so I'm going to recap what I've already gone over, and hopefully it's not too confusing for you. I just got the first couple definitions down and then we'll kind of go from there. Throughout this program, y'all, we're going to have 3 videos that I create. Hopefully they're not terrible for you, hopefully they're informative, a good review, and that it helps you understand the task at hand. So today we're going to be talking about 8.4a. That is the first out of 3 teaks that we're going to be discussing through Jumpstart. And this teak is to use similar right triangles to develop an understanding of slope, also known as m, given the rate comparing the change in your x values for any 2 points on the same line. So I've got that up here. That's a lot of verbiage. That's a lot of words. I don't necessarily need you to memorize that. I just want you to see that I'm not just making this up for the sake of making stuff up. So what I want to do first is I want to break down that teak and I want to discuss the vocabulary in it. I want to make sure that you understand some of the bigger words, some of the mathematical words, so that as we move forward into this, you're not confused on what I'm trying to say. So the first word we're going to talk about is similar. Now similar talks about shapes predominantly, and so what it really means is it's the same shape, so triangle and triangle, the same angles, so this is the 90-degree angle, this is a 90-degree angle. All triangles have 180, and so if I have 90 and 90, that means that these two are probably going to be the same as well. But the biggest difference is that they're different sizes. Notice we have a large triangle and a small triangle. So again, same shape, both triangles, same angles. We have the 90 and the 90, but different sizes, a big one and a small one. Okay, right triangles is emphasized at the very beginning of this teak, and that right triangle is supposed to be what we're using to compare our slope. And it's really important that it's a right triangle because what that means is we have a 90-degree angle. Now, I know you guys have seen this symbol a lot, and you're probably thinking, well, what does it matter? It's just a triangle. Yeah, I agree, but the 90-degree marker emphasizes that this is a straight line. It is straight vertical, straight up and down, and this line is also a straight line horizontal, not vertical, because it's going from side to side. But what that means is that these are perpendicular lines. They're both totally straight, and if I were to turn my paper, I've got the exact same 90-degree angle marker going this way. So one is going straight up, one is going straight to the side. So that's what's important about it, because when we're looking at slope, we can't have these wobbly lines that are kind of goofy or bent. We want them to be straight, perfectly straight, to form that straight up and down. Okay, the next word is slope, and hopefully you know this word from last year. It was most of your 8th grade curriculum. There's a lot of different terms for it. We've got m, which is just another term for slope. We've got rate of change, which is how often something is happening. Okay, so for instance, if you were to go to the store and you wanted to figure out how much a 12-pack of Dr. Pepper was, well, each can has a specific price, and you're going to multiply that price by 12 to get your total cost. Or let's say you go to an arcade. Each game costs a quarter to play. Well, the rate is 25 cents per game. So it's just that constant cycle. Rise over run, we're going to focus a lot on that today. That's going to be where a bulk of this video takes place. I'm sure you've heard that. What that is implying is how much are you going up or down versus how much are you going from side to side to get to each point. Another term you might have heard is unit rate. And all of these things really mean the exact same thing. It's also steepness. It's really just how much your line is affected on a constant change. Okay, so next is rate, and that's what I just talked about. Rate is going to be the reoccurring amount or distance. The reoccurring amount or distance. So rate is how often something happens. If somebody sneezes every 30 seconds, then the rate is that there will be a sneeze every 30 seconds. For my basketball fans out there, if Luka is scoring 27 points a game, then that means that the rate is 27 because he will score that every single game. Okay? Average can kind of be thrown in there, but I'm not going to jump too much into that one. X values, this is a part of our ordered pairs, and if we have a graph here, we usually have points on here. So if this is my origin, or 0, 0, this is going to be a point right here, and we're going to call this point 0, 1. I lied, I apologize, please forgive me. 1, 0, 1, 0, because on our x-axis, we moved over 1, and on our y-axis, we went up 0, so we went over 1, up 0. The x value in your ordered pair, I'm going to write this a little bit bigger so you can see it, is always the first one, and it's always referring to this horizontal line. Okay, we are going to talk about y values, but x value is specifically mentioned in the TEK, and that's why I want to stay specifically on that one. So x value always comes first in your ordered pair. Slope formula, we'll talk about this in a later video, but I just wanted to go ahead and introduce it because it's in the TEK, and that formula is going to be y, the same y that you're seeing up here, is equal to, which equal means the exact same, m, we saw m earlier in the video because m is up here with slope, x, yes, the same x that you're seeing in your ordered pair, plus b, which we'll get to at a later date. So the slope formula is y equals mx plus b. I'm sure you've got that memorized. Yes, I'm a math teacher, and yes, I talk about this a lot, but that's just one of those formulas that's just stuck with me for as long as I've ever learned this. And then finally, a line is going to be a bunch of little points that come together and ultimately form this nice line that we see on a graph. And on that graph, we often have other points that are a little bit more specific, and that's what we use to find our slope kind of throughout the process. So that's the vocabulary. Hopefully those words all make sense to you, or at least are ringing a bell. What I'm going to do is I'm going to go ahead and flip over my page, and we're going to talk about some different ways that we can find slope. All right, so I've got 4 examples here, and I want to just kind of explain to you a few different ways to do this, how we compare these, how we talk about them, and how they lead to bigger and better things when it comes to slope. So the first one I've got here is example 1. Now this is a right triangle. I didn't have that marked at first, but that is very important to this idea. And what we're going to do now is we're going to try to figure out how steep is this line that we see going across here. Now the easiest way to do this is we talk about rise over run. Okay, I'm going to show you a couple different ways. I think it's better to see the way our brains work, to see it in a few different ways. But rise means to go up and down. So the line that's going up and down is this one right here. And so if I'm at this point, I'm going down 1, 2. So my rise is going to be 2. Okay. And then my run is when you run, you don't run up and down, you run straight across. Think about in track practice, or think about when you're sitting in your quarantine and you're watching people run out the window. They're not running up into the sky, they're running on the road straight across. So that's going to be from here, we're going to go 1, 2, 3, 4, 5, 6. So we end up with 2 over 6 as our slope. Now we want to always simplify our slopes. It's imperative, we have to do it. Just like simplifying fractions, we're going to figure out what number can I divide both of these by. Well, they're both even, so they're both divisible by 2. So if I do that, I end up with 1 over 3 as my slope. What that means is that for every point, I'm going to go up 1 over 3, up 1 over 3, up 1 over 3. Okay? Okay, so now let's think about why in the world we want to have triangles. Yes, it's nice that we can see the triangles, we can move up and down them, blah, 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 blah. Okay, but the real thing is we want to be able to take our points, and we're going to talk about that towards the end. So when I look at these, there are 2 points here, and those points are going to help us find our slopes by using the slope formula here in just a little bit, okay? All right, so let's move on to the next picture. So here I've got 2 triangles. Now the 2 triangles is a little bit more advanced than what we just did, but it's going to also help solidify or secure or prove our ideas here. So I'm going to pick my 2 points here. Okay, so I'm going to take this one. Now remember, it's always going to be rise over run. I want you to memorize that phrase, rise over run. So we're going to figure out how much did I rise up versus how much did I run up. So we're going to go up 1, 2, 3, 4, 5, 6. So my rise is going to be 6. And my run is going to be 1, 2, 3. Okay, now once again, what did I tell you? We have to simplify that. What can I divide both 6 and 3 by? Well, we can divide them both by 3. If I do that, 6 divided by 3 is going to give me 2. 3 divided by 3 is going to give me 1, and so therefore my slope is just going to be 2. Okay, now let's just say out there you're thinking you can't count, you're a knucklehead, you're a chucklehead, whatever you want to call me, I did something wrong. Let's try the smaller triangle. If this is correct, then we should get the exact same slope for the small triangle as we did for the large triangle. So we're going to do our rise. We're going to go up 1, 2, 3. So my rise is 3. And then we're going to do our run, which is going to be 1.5. I want you to look really closely. I'm in the middle of these 2 points. That's where we get that. Okay, now, you're thinking to yourself, well, we can't simplify a fraction that's on top of a decimal. That's weird. You can't do that. Yeah, I agree. But since we're not technically in a fraction, it's technically slope, we can afford to look at this a little bit differently. what I'm going to do is I know that all division problems can be represented as a fraction. What this is really telling me is 3 divided by 1.5. Okay? Yes, I know you had calculators last year, but this is easy enough math. We can figure this out. We got to move our decimal out of the divisor, and there's technically a decimal right here, but we got to move that one over. So now what we're going to have is 15 going into 30. Well, 15 can't go into 3, but 15 can go into 30 twice. And therefore, a 2 here and a 2 here, these are the exact same things. Okay, so as you can see, the triangles are super duper helpful with this. I did make a slight blunder earlier. I gave you the slope-intercept formula, and I should have been giving you the slope formula. So I want you to just pause with me for a second, and I want you to look at this new formula I'm going to give you. And this formula is going to be m equals y2 minus y1 over x2 minus x1. Now these x's and these y's are the exact same thing as the ordered pair x and y's. So keep that in mind. The reason the y's have to go on top is because just like in the rise over run formula, the rise is done on my y-axis. That's when we go up and down. The run is done on my x-axis, which goes from side to side. So that's where I'm getting that formula from. So let's break this down. Okay, let's first figure out what these two ordered pairs are. So this is going to be 0, 1, 2, 3. So we've got 0, 3. And then over here, we're going to have 1, 2, 3, 4, 1. There are my two ordered pairs. Okay, hopefully you're with me on that so far. Now I'm looking for 2 y's and 2 x's. Now I'm going to tell you it doesn't matter because it doesn't. Which one do you choose as long as you use them consistently? So here's what I'm going to do. This is going to be x number 1, and this is going to be y number 1, x number 2, and y number 2. Now I'm just going to take the numbers that I have and I'm going to input them into my slope formula. So y2 is going to be 1 minus y1, which is 3, over x2, which is 4, minus x1, which is 0. Okay? Well, 1 minus 3 is going to give me a negative 2. 4 minus 0 is going to give me 4. So my slope is going to be negative 2 over 4. So once again, ladies and gentlemen, we must simplify these. I can divide both of these numbers by 2, giving me a negative 1 over a positive 2. And that's your slope. All right, let's look at this last one, and then this video will be done. First thing we want to do is we want to go ahead and identify what are my two ordered pairs. So we're going to have negative 1, negative 2, negative 3, 1, 2, 3. So it's going to be negative 3, positive 3. Down here, we're going to have 1, 2, 3, minus 1. So we're going to have 3, negative 1. Once again, we're looking for the m, or slope, equals y2 minus y1 over x2 minus x1. And now we're going to number these, x1 and y1, x2 and y2. So y2 is negative 1 minus, so notice there's a negative 1 here, minus 3. That's going to be over negative 3 minus 3. Negative 1 minus 3 is a negative 4. Don't forget your integer rules. Negative 3 minus 3 is a negative 6. So now I've got a negative 4 over negative 6. Now, bear with me. This gets a little bit confusing here. We're going to divide both of these by 2. That's going to give me a negative 2 over a negative 3. But one final rule. When you're dividing a negative divided by a negative, it becomes a positive, and therefore my slope is going to become a positive 2 over 3. Unless I've done my math wrong, but I don't think I have, so there we go. All right, guys, that's how you find all of your slopes. That's how you compare all of your answers. I hope you guys enjoyed the video. Hope it was clear enough for you. If you've got any questions for me, please let me know, and we'll be more than happy to go over them. All right, y'all. Talk to you later. Bye.